Now, today I think you are already at worksheet 47. I think just to clarify, we have 48 weeks in a year, which means we have 48 worksheets. You are already at 47, which means that next week's the last lesson of the year. Then we'll go on a 2 weeks break. Okay, so this two today actually is to give you a head start to primary four science. Particularly, actually today we'll be covering on matter. Okay, so matter is something that I would say is not an easy topic, but we will try our best to answer it. Okay, so how we go through the how we actually do the lesson is that usually I'll go through half of the questions, and then later on, in between, I'll give you a very short break. We'll play some games, then we come back to finish the other half of the questions. Okay, so for a start, I think we can start off by watching a video on matter. Okay, because I'm sure you have not gone through the topic yet, right? You are P3 this year, going P4, right? Yeah, okay. So we'll watch a quick video just to give you some idea on the topic so that it will be easier for you. Okay. Where is it? This one? No, not this one. Just matter. Okay, this is interesting. Okay, just to give you an idea of what matter is, let me share some.
Teachers will work with you and your child to set ambitious, achievable goals.
That it takes up in the glass. So all Hey, what's matter? No, not what's the matter. Obviously, since you're here with me, you're pretty awesome at the moment. You might have heard that everything is made of matter, and that's true. You, soccer balls, iPads, even your pet Fluffy, all made of matter. So that's interesting. But what is matter exactly? The scientific answer is matter is anything that has weight and takes up space. You already know about weight, right? That's just how heavy something is. Like if you've ever been to a doctor's office, the first thing they do is have you stand on the scale so they can measure how much you weigh. As for taking up space, another way of thinking about it is that all matter has volume. It simply fills the area it's in. When you pour water into a glass, for example, the water's volume is the amount of space that it takes up in the glass. So all matter has volume and weight. But it sure doesn't all look the same. Well, that's because matter comes in different forms, or states. Liquids are a state of matter that I'm sure you're familiar with. If you've ever poured yourself a drink while trying to watch TV, you might have noticed that liquids take up space, because once the space inside your glass is full, right on the carpet. Sorry, Mom. You also know that water has weight if you carry a water bottle. As you drink from it, it gets lighter because you're removing water from it. Solids are matter too, of course, probably the most obvious kind. Rocks are solid, and so is ice, which is just solid water. Soccer balls are solid, iPads, your pet Fluffy, and every single guy in One Direction. And just like rocks, all those things have weight and take up space. Now, you know what's weird? Sometimes matter can't be seen or felt, but it's there. Like the air we breathe. Air is an example of gas, the third main state of matter. And I probably know what you're thinking. How do we know air, or any gas really, is there if we can't see it? Well, we can prove it by doing an experiment. Science. Let's start by asking the question, is air matter? Because if it is, it should take up space and have weight, right? To see if air takes up space, look it, I can easily drop an empty balloon into this little box, but a full one won't fit. That's because the air that fills the space inside the balloon is bigger than the space inside the box. Now, does air have weight? Let's try something else. Take 2 empty balloons and tape them to the ends of a meter stick. Then we'll hang the meter stick on a string so that it's perfectly balanced. Now let's see what happens if we blow up just one of the balloons and put it back on our meter stick. Check it out. The end with the full balloon sinks. It weighs more than the empty balloon because the air gives it extra weight. The balloon full of air will always weigh more than the empty one, because air is matter and matter has weight and takes up space, whether it's a liquid, a solid, or a gas. So listen, the next time someone tells you that something doesn't matter, you can tell them to their face that technically everything is matter. And tell them Sabrina said so.
Okay, now I agree with Sabrina on certain things, but there are certain things that I don't agree with her. She said that everything is matter, but there are also things that are not matter, like for example, light and shadow, right? And heat, okay? So all these are not matter. But most things, yes, I would say are matter. Okay, so under matter topic, actually, you need to know gas, solid, and liquid, these three states of matter. Okay, so let's go and take a look at the questions now. And as we go along, then we will introduce some of the concepts that you need to know. Okay, now, first question. Study the diagram below. Which of the following statements is true? So when we talk about true statement, we put a tick below. Okay, it must be a statement that is correct. So let's see statement A. Is statement A true? Both objects have the same size? Both objects have the same mass. Yes, right? Because if you look at this, this is what we call a beam balance. A beam balance is something that measures mass. So if you look at the beam balance, it's actually equal. It means that the mass is the same. Okay? Of course, it doesn't have the same shape, you can tell. Now, when we talk about volume, what do we mean by mass? Okay, mass is the amount. Okay, the definition of mass, amount of matter in an object. Then in terms of volume, volume is actually the amount of space an object occupies. Okay, so of course, if you take a look at these two objects, they don't really occupy the same amount of space. Okay, in fact, it seems like this ball occupies a bit more space, so which means that it has a bigger volume. Okay, so the answer is B. Any questions for this? Nope. Okay, no, we'll move on, huh? Okay, next question. Figure 1 shows a balloon filled with air floating on water in a container. Okay, so when the balloon was pushed downwards, some water in the container overflowed as shown. Which of the following could be concluded from the overflow of water in figure 2? You can unmute yourself and speak, yeah?
B.
Very good. Okay, because space is the it occupies space. When it goes down, basically it's trying to use up the space inside, which caused the water to overflow. Well done. Okay, it doesn't really show the air can be compressed here. There are other experiments that show the air can be compressed, but not in this situation, yeah? Okay, now question 3. Jessie set up an experiment as shown below. She placed an empty metal tin with its lid closed into the displacement can and recorded the volume of water collected in the beaker. She added 5 identical marbles into the same metal tin and repeated the experiment. So now, this one is an empty tin, okay? Empty metal tin. This one is a metal tin with 5 marbles. Okay, so how much do you think will be the water collected?
C.
Very good. Yes, okay, because right, the marbles would have occupied a bit more space. And when it occupies a bit more space means that it's going to displace out even more water. Okay, so if it's going to displace out even more water, the answer will then be 80. All right, good, well done. Okay, next question. We will start by question 5 before you go for your short break. Then I will start the game. I think today's lesson might be a little bit short. But if let's say you want to do some other activities, we can always do that after our questions, okay? All right. Okay, so we have a ball here. Mr. Sim pumped air into the ball. He observed that the size remained the same. Okay, so I think there are certain keywords in the question. The size remained the same. Okay, so which of the following are true? Okay, true. After more air is pumped into the ball. Okay, let's take a look at the first statement, yeah? The mass of the ball increased. Does it increase?
Yes.
Yes, very good. Because even though the ball does not change shape, the shape remains the same. When you pump in more air, you are actually increasing the mass. Remember, the mass is the amount of matter in an object. Yeah, so this is true. Good. We are looking for ticks, remember? So this is tick. Okay, next one. The mass remain the same. So this one is definitely wrong, right? Because the first one is already correct, right? When we say the mass increase, right? So the second one says that it remained the same. So this statement is actually wrong. Now, next one, the volume increase. Did the volume increase?
Yes.
Okay, again, what is volume? Volume is the amount of space an object occupies. But if you think about it, the size remained the same. So did it occupy more space? Did the ball occupy more space? The size actually remained the same. So did it occupy more space?
No.
No, right? Okay, so the volume didn't increase, right? The volume remained the same. The volume remained the same because the size remained the same. So it does not increase. Okay, so therefore the answer is B. You understand this one? Okay, so volume is the amount of space. So if the size doesn't increase, right, it doesn't become bigger size, it means that the volume that it occupies also stay the same. Okay, if it becomes bigger in size, it means that it occupies more space. Can, Sophia? Yeah, good. Okay, next one, huh? Okay, over here we have Johan poured 500 ml of water of the same temperature into each of the 3 plastic containers, A, B, and C, as shown in the diagram below. He placed 3 containers at the same location and measured the amount of water left. Okay, amount of water left after 6 hours. Now, this one I wouldn't say is totally under matter. This one has got to do with rate of evaporation. Okay, that means how fast the water evaporates. And how do we determine which one evaporates faster? We will look at the exposed surface area. Okay, so this is the exposed surface area, these 3. Okay, this is what we call the exposed surface area. So if you notice, let's say if you have a towel, you want to dry it faster. Okay, will you want to lay it out open or you want to fold it? Which one dries faster?
Lay out.
Lay it out, right? Because when you lay it out, the exposed surface area is larger. And when it's larger, the water in the towel will evaporate faster and dry faster. So it's the same as these 3 containers. So A, B, or C, which one do you think the water will evaporate